Hello everyone, this is a video lecture for Algebra 1314. We're going through the workbook. We're in 4.2, logarithmic functions, yeah! Okay, well, I'm just making it exciting. So, okay, we call them logarithms or just logs, just log, because that's a lot of words, and log. I never noticed. It's like arithmetic there almost, right? So anyways, logs. What are logs? And what they are inverses. I'm gonna put this here. Okay, inverses to your exponentials, and then they are. I'm gonna put finger quotes around them because you can kind of rework it a little bit. But they're kind of like saying inverses to the exponentials, and that doesn't sound great. I mean, it sounds great. I just didn't say it. Well, no, I said it. It was just that I wrote it. Okay. What a great start to this section. So what I want to do is not any of that. I want to do my own thing. Do I have room? Look, I'm going to use this up here a little bit for my own stuff, okay? So just ignore what we did last time. I want to do my own little thing here. And so let's talk about logs. My exponential function kind of looks like this to start with, and we showed that last time. What I want to do is I want to rewrite it in logarithmic form. And so what it looks like then is going to be log base b of y equals x. Okay? Pause. So these are literally the same. They are equivalent to one another. They are the same. Okay? If you say this, it means the same as that, and vice versa. So you can go back and forth between these two. That's good. And let me do one more to show you, kind of like a. I want to say it as a pattern. I want to call it a pattern because that's what we'll be using a lot. So let's just say you start with this, and it says to rewrite it in exponential form. So I'm going to do that for you. It's b to the y is equal to x. Again, these are equivalent. These are the same thing right here. They're the same thing. So there's a pattern to this, okay? There's a pattern, and I'm going to have to use a different color to be able to show you what's all that pattern stuff is. Let's use some red. I like red. Red will be great. So first off, I identify my base, okay? So what I did here, like, I need to do an example. Let's do an example. So let's say I have, I'm gonna use numbers. Let me use numbers. Hold on. I want to do numbers. I want to do that, but let's just finish this up. So okay, I keep going back and forth on you. So base b is what I identify. Notice that the y is by itself here, and b and x are next together. But now it's b and y that are really close together, and x is all by himself. Okay, so just let's take that back in over here. I identify my base, and I'm saying, well, b and x are good friends, but no longer. He's not my friend anymore. But y was all by himself, and now we're friends this time. So it's not about switching or moving things around. I call this method friends. I call it friends because they make friends, they lose friends, that kind of thing. I want to do an example and with numbers because numbers make a lot more sense. So let's do 2 cubed is equal to 8. Okay, very simple, and it says rewrite that. So I have to identify my base, and it's a base 2. So now what I got is log base 2 of something, and then I got something else. And I want to say, okay, well, my 2 and 3 were good friends. I mean, they're like right next to each other on number line lane, right? They're neighbors. But no longer, I don't like you anymore, 3. Get out of my lawn. And then 8 was all by himself. He just didn't know what to do. And so 2 took him in and said, hey, man, I'm going to be your friend. We're both even. Look, ooh. I don't know. I'm just making up little stories here. I know that's kind of silly. But this is the same as that. What I just did was I rewrote it. And there you go. So I identify my base. And then I kind of like switch up my friends. I say, well, 2 and 8 are now good friends, but 2 and 3 are no longer friends, okay? Let's do the same over here. And I know it's going to be very redundant looking, but I'm going to have 3 is equal to log base 2 of 8. So this is my original, and I want to rewrite it. And so again, I identify my base as a base 2, and then I got up top and on the side. Ignore that little scratchy through here. So 2 and 8 were good friends. No longer. You ate all my pizza. See you later, bro. It's just funny. And then, yeah, 2 and 3. Oh, look, we were neighbors the whole time. We're friends again. Yay. Stay off my lawn. Anyways. The main idea here is that we're switching their positions. You know what your base is, you identify it, you write it down, and then the other two kind of just move around, okay? I think it makes a lot more sense with the numbers because we're used to that. And are these statements true? Is 2 cubed equal to 8? Yes. Is log base 2 of 8 equal to 3? Probably. So you can test that, and I'm going to show you right quick how you could. Log, this is in Desmos graphing, by the way, but we'll talk more about that later. There you go. So I just proved that it works, and that's fine. So let's do this a lot because I want to practice a lot with you. And that's what we're going to do right here. Let me change my color back again, or at least something else. Red's a scary color. Ooh, now it's purpley. Indigo. I'll call it indigo. Ooh. So we're going to rewrite these things, and that's it. We're just rewriting it. We're not solving. We're not doing anything else. We're just rewriting. So identify your base as a 7. So I got 7, and then I got up top and on the side. It's kind of like the setup of what I need to do, and I just need to fill in the boxes. Well, 7 and X were good friends. You have exceeded my limits. You excuse yourself in my presence. Yeah, I've been doing this jokes forever. I'm so sorry. But 3 was all by himself, and oh no, 7 and 3 were both friends. We're both prime. There it is. Both prime. This is the answer that they're looking for. In a way, you did solve for X, but it's not that. You don't need to like get a number. They want you to like rewrite it and leave it alone. Okay, that's what the homework says. Rewrite it, leave it alone, don't simplify, blah, 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 that kind of thing, okay? So let's repeat the same process. I got a base 3, got up top on the side, and so then 3 and 27 were good friends, no longer. Y was all by himself. Why not come hang out together? Haha, I'm sorry, I'm just losing it. I've said these jokes for so many years. So, identify your base is a 3. Log base 3 of something equals something else. And so 3 and negative 3 were good friends. I mean, like, look, they even had the same last name, but, you're just so negative. Get away from me, man. And then 1 over 27, I know that nobody likes them because he's a fraction, but, you got to have some love on them, right? So there you go. Last one, I identify the base is 11. So I got log base 11 of something equals something else. And then 5 and 11 were good friends, no longer. 5, you're out of here. X is all by itself. Now X has got a friend with the 11. And those are the answers. You don't have to do any other math. You're not solving or anything. That's it. You're done. There you go. Okay? We will start solving here on the next page, like right there. But for now, that's what we got. So we're switching things around. Look for your base. Do your friends. There you go. Okay? And we're going to keep doing that a lot as we keep going. So it says find the exact value. Honestly, it's just basically like equals, 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 and you fill in the box. And guess what? Desmos does that really awesome. I'm not going to stick around with just Desmos here. Look, there it is, 4. There's your answer. You're done, 4. Log base 2 of 1/2. You might be asking me, hey, Chad, how you get that little base thing going on? So let me just talk about it. So I got log, and then I put a 4? No. You got to bring it down. You got to put a base on it. So what I do is shift minus sign. You can see how I'm down low now. Shift minus sign. And then I got a 4. But I can't keep typing down there. I need to get back up. And so I think what I normally do is just arrow to the side. See how I'm back up again. And that's when I put in my numbers. And so I got 1 over 1024. And then it just gives you the answer. Okay, so I have all my answers here. It's very easy. It's done. But I want to show you by rewriting it how we can get the same answers, okay? So I identify my base as 4. So log base 4 of, and then I got blank is equal to, oh, sorry, I messed up. Hold on. What did I mess up on? Hold on. Let me just pause very quick. What did I mess up on? It's because I had a log, and I just wrote a log again. That's not my point. No. I need to rewrite it in exponential form. So basically, I have a 4 and then up top and on the side. I have to rewrite it in a different form. Okay, so identify the base. We're good. 4 and 256 were good friends. No longer. See you later. And then box is all by himself. Come here, buddy. Box. What's inside? What's inside the box? Anyways, let's see what's inside the box. So I'm saying 4 to some number is equal to 256. I'm going to go back to scientific for a minute. So 4 to the 1? No. 4 to the 2? No. 4 to the 3? No. 4 to the 4. Oh, there it is. There it is. It's 4 to the 4 is equal to 256. So what was originally in the box? A 4. But we already knew that. Same thing here. 2 is my base up top on the side, 1/2. And then I'm saying, what goes right here? Well, notice that this is flipped. When you flip your base into a fraction, that means that your power is negative. So what's in your box is actually -1. And, well, I proved it. There you go. And then finally, this guy, because he's a fraction, he'll flip again. Okay, so for sure we got a fraction. But 4 to some power is equal to 1024. And so if you went one more, so it's 4 to the 5th. So it's a 5 up here. It's a 5, but not just a 5 because it's a fraction. It's a -5. Okay? All of this, though, is circumvented with a little bit of Desmos. Note that I'm using Desmos graphing for these guys. If I tried to do this in Desmos Scientific, it will say, no, you can't do that. So there you go. See? There it is. This calculator doesn't support this, blah, 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 blah. And so it's just annoying, and we just, there it is. Okay. Moving on. Now you know the tricks. Now you know what's going on. Basic log properties. What did I put in here in my workbook? I don't know, man. Oh, yeah. So, I just recopied what I had already done, and so I'm saying that this is the same as saying that. And that if I had this, then I can rewrite it saying this. Yay. Okay. What I also did right here is I said log base b of b to the x. What happens is you can cancel your bases and you're just left with an x. That's kind of nice. And if you got b to the power of log base b of x, similarly, you cancel your bases and you're left with just x. So there's a little bit of interesting there. We're going to prove this stuff here in just a second. Blah, blah, blah. Here we go. So let's find the exact value. Desmos. Exactly. Gosh, man, why didn't you ever think to use something else? I mean, every time, okay? So when you're on a quiz, when you're on a test, it's very nice that you're learning this stuff by hand, and you will, and I will teach you. And you will have to use it occasionally. I mean, these skills are used in problems later. You will have to learn this, but if you're seeing this on the test, you better do the easiest thing possible to pass. I want you to pass. This is how you pass. You just do whatever's the easiest, the quickest. This is what I would do. Okay? But on the homework, when we're learning, we need to do this the long way so that we're ready for the next sections, okay? Because you will be using this friend stuff a lot. Okay, so I got 3, and I got up top and on the side, 3 1/3. We're good friends, but you're a fraction, and leave me alone, bro. And then you're wondering what goes up here. Well, notice that it's a fraction. It's the same base, but it's a fraction. The power then must be negative, -1. So identify my bases as 7. There's my 7. 7 up top on the side. Well, 7, again, this is equal to box. 7 and the square root of 7 were friends, but square root. Get rid of your square root, and then we'll be friends again. A box showed up on the porch, though. Ooh, what's inside the box? And so I'm looking for what would make this happen. 7 to some power is equal to the square root of 7. If you don't know, I'm telling you right now that the square root is technically a half power. It's a half power. And so my answer is 1/2, okay? Just like a square root is a half power, a cube root will be a third power, okay? And a 9th root is 1/9, and etc., okay? Was there something else? I did write something else over here. Hold on. Okay, here's some more properties. If you have log base b of 1, it's always equal to 0. And if you have b to the 0, it's always equal to 1. So these are kind of like saying the same thing. If you have log of 1, it's always a 0. Anything to the 0 power is always equal to 1. We already knew that one. So similarly for this guy, which I'm kind of squishing now, I have log of 1. Automatically, the answer is 0. You don't have to think about it. You just do it. And we can test it. I mean, here you go. So log base 5 of 1 is 0. It doesn't matter what base. You can change that to a 6, to a 10. It's all the same. See how these 5s are the same here? So you cancel them out, and you're left with a 2. Wow, that was so easy, Chad. And the same with these 2s. They cancel and leave a 4. Can you still do this in Desmos? Yes. Yes. But I'm trying to show you some of the neato burrito features. I don't know where you find those at Walmart. Probably right next to the Cool Beans. Neato burritos are right next to Cool Beans. Okay, whatever. I'm trying to make it funny. Yay! Okay, so they want to talk about graphs of this stuff. This is the same as what we had on the last section. So because you still have it written down, I'm sure I know I have mine written down. That's what we had. What they're wanting to do now is switch it. Notice that base 2, log base 2, they're the same thing. So we're just swapping my x's and y's. And that's going to be important later. Switch x and y. Where have we heard that before? It's in inverses. And I already said it was inverses. So what they're wanting you to do in this case, which is not on the homework, what you're going to do is do this sort of thing. You're literally just swapping your x and y values around. Okay, so like I just, these two right here, now I just swapped them. There you go. That was it. Now, what does it look like to have inverses? So my exponentials look like this. This is an exponential. And then my logs look like this. So that's a log. And they are inverses because they are, I'm going to write inverses. Because they are reflective about the y equals x line. Again, all this goes back to like chapter 2.7. Okay, great. But now you have a little bit of idea about what they look like, okay? If we were going to type that into Desmos graphing, so we got 2 to the x, and then I got log base 2 of x, and there you go, okay? So they're kind of like the same thing, but they're also just, you're switching your x and y. Blah, 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 transformations. Again, I would recommend Desmos for this class. And so I'm just going to go one by one to see if I can get that to work. And I tell you, I already got it. See how it's colliding here at 5? Right here at 5. So we're done. That was it. Super easy. And then this guy here, I am just going to skip ahead. And it's colliding here at 1. Oh my gosh, that's a 1. It was this guy the whole time. Oh, wow. Desmos. That's the sloppiest Desmos ever, but yeah, you know. Okay. Domains of logs. So I'm going to just write what I normally do. This is going to be the inside is set equal to 0, and this is going to be either a start or a stop point, but you must only use parentheses. You don't have an actual solid because it's not a square root, but it's very similar in the same style as a square root. Anyways, inside equals 0, solve for x, you get a 1. Easy enough. And so my domain for this one will be very simple. It's 1 to infinity, but notice that again, I'm using my parentheses here. This one's a little bit different because it's backwards. And if you remember how the square roots work, whenever you have a negative x, it actually, like x equals 2, we still solve for 2. But my domain starts at negative infinity, and then we go all the way until 2. I want to show you that you can prove this to yourself. Log base 4 of x minus 1. Notice that we're starting right here. I wonder what that number is right there. It's a 1. Oh, wow. And then we go on to infinity. All right. So then this guy here, when I graph this, notice there's no base, but we'll talk about that in a minute. I type it in, and look, it came from negative infinity all the way up until, hey, where's it stopping? Where's that vertical line? It stops at 2. Oh, wow. We got it. We got it. Okay, so this one here is definitely an oddball one. We can solve for x and get the 3, but because the square, what's happening is that you're going to only have a hole there. I don't even know if this is on the homework because this is a little bit more complex than the other questions. But we do have Desmos to help just in case. And you can see that, yes, we got negative infinity, positive infinity for sure, right? It's on both sides. But there's this weird, like, hiccup right here. And where's that hiccup? It's at 3. Oh my gosh, how did I know? And so we can't actually use 3 because they're not touching. It's getting really close, but not touching. And then we just use everything else around it. Okay, I don't even know if that one's on the homework, but, I'm doing the workbook here. That's what it is. There you go. I recommend using Desmos to at least show you and help you and remind you about which ones we're going to use. Okay, new topic, common bases, natural bases. So the common base is base 10. Whenever you see a log by itself, so just log x, what that means is log base 10 of x. And why is 10 the common base? Look at your fingers. Oh, I got 10 of them. Wow. Yeah, 10 fingers means... I'm dead serious. That's why that's the common base, because we all got 10 fingers. And so natural base, so when they start using ln of x, what that means is log base e of x. So that's ln, log natural. Okay, well, you get the idea. Log natural base, okay? ln, Ln. Okay, I have to say this. I say this in every video of mine when we approach this topic, okay? On the homework, you're going to see this thing a lot. You're going to see this thing. And if you chose to use Arial font, it kind of looks like IN. That is not the case. What you need to do is Times New Roman font, where it's an LN. Okay, it's an LN. LN. You know how many times people ask me, they're like, hey, I'm typing an IN and it looks fine, but it's not working. IN. I'm like, why is it an I? It's an L. And I know clearly that they didn't watch my videos because I mention it every time. So that's an L for log, logarithm, LN. Okay, I talked enough about it. So it says find the exact value. What they're wanting to do is change the base to what it's supposed to be. So log base 10. There's a lot of ways we can do this, but log base 10, and this is 10 squared, and then the 10s are going to cancel, leaving a 2. But equally easy, and now notice I'm in scientific mode now. Ooh, there you go. See, I just typed the original in. Same thing here. That's an ln e to the 9. What's happening is that this is log base e of e to the 9. That's a 9. And then the e's cancel and leaves a 9. Now, again, you can use scientific for this, so it's like way not cheating at all. There you go. And then finally, e to the ln of 144. Again, that's e to the log base e of 144. As you guessed, the e's cancel, and there you go. Sweet. What you probably are learning is that Desmos good. Just in case I forget some of this stuff. Desmos good. Oh, I forgot natural bases. I forgot E. Did I say that at some point? I did say it. Okay, I forgot to put that in there though. Sorry. Okay. So example. Boom. We got X is years after 5. No, just X is years. X is your age from 5 to 15. It says age 5. So X is equal to 5. Go. So 62 plus 35 log of 5 minus 4. What we have is log of 1. Do you remember log of 1 is equal to 0. And 0 times anything is 0. Your answer is 62. And yet again, because it has the common base, you could just do this, and there you go. Fantastic. This is the last question. So it's kind of fuzzy to see, but that's actually 10 log of 10 to the 12 times I. That's an actual I right there. That's an I for intensity. And this is your intensity. And so basically you're going to plug that in for I. And so what it looks like is kind of silly. 10 log 10 power 12, and then times 8.6 times 10 power 5. There we go. And we got a number, and we're done. I didn't even read the problem. Oh my gosh. How can I do the math without reading the problem? Okay, let's talk about it for a second, okay? So it's decibels of a certain animal, and it says it can be heard 500 miles away. What? What? I'll give you a second to think about what animal could be heard 500 miles away. It's a whale. Yeah. Go look it up. It's a whale, and it goes or whatever it does. That's a whale sound? I have no idea, actually. But it goes and 500 miles away, you can still hear it. So when it's producing that sound, it's at a level of 180 about decibels. It says 160 will rupture your eardrum. So don't go swimming with the whales, because they'll go and then your ears will start bleeding, right? And when you're swimming in the water, and then the whales leave. And then the sharks come. No! Because you're bleeding. That was my point. So don't go swimming with the whales, because then you'll just get eaten by sharks. Kind of strange. If that was a bad ending, I'm sorry, but we are done. So that's nice. Thank you very much. Have a great day.